tomorrow will be better. A dryer uses 100 millivolt to draw 20 coulomb of charges. What is the work done? Now the dryer is said to operate at 240 volts, drawing a current of 30 amperes. Calculate the power of the dryer in the second case. Follow me, dear friends. Solution. I'm fond of telling students that there are many formulae that could lead to a same quantity, but whichever formula we use depends on what we are looking for and most essentially what we have at hand. Now they're asking in the first question for the work done. Now in the context of electricity, work done, or let me define it from this other angle, the potential difference across maybe a bulb or any other appliance is given by the work done per unit charge. This is the basic definition for potential difference, is the work done per unit charge. So from this formula we can deduce that therefore the work done W will be equal to the potential difference times the charge. All right, so work done will be equal to the potential difference times the charge, which in this case will be equal to, now watch out for this small trap here. The potential difference here has been given in millivolts. Here we have to take it back to volt. So the number of charge we have 20 times the potential difference 100 millivolt, which is equal to 100 all over 1000 volt. We have to bring it to volt. All right, so we have 100 all over 1000 volt. If you do this correctly, you're going to have that the work done will be equal to 2 joule, and this is the work done. All right, now look at the second part of the question. It says now the dryer is said to operate at this, so now we are on another voltage. All right, so we can call this even V1. Now there's a certain V2 which now is 240 volt, and it draws a current of 30 amperes. Now current I is 30 amperes. And here's the question: find the power of the dryer for this circumstance, for this condition. Okay, now again, once more, we know we have been told that power is given by the work done per unit time. Okay, now in the context of energy, force and power, we know that work done will be equal to what the force times the distance moved by that force. But in this case, as we just saw in the previous question, the work done actually, we will say, but the work done is actually a product of the potential difference and the charges. All right, so if we replace this here in this formula, we will have that the power will be equal to, instead of work done, we will write the potential difference times the charge, Q now all over time. Now if you're attentive enough, you will realize that Q all over T is a quantity which is well known, which is equal to the current. All right, therefore, or this implies that power is nothing else but the product of the potential difference times the current intensity, which is equal to, here the potential difference 240 times the current, which is 30. And if you punch well, this should be able to give you 7,200 watt, because watt is the SI unit of power. Tomorrow will be better.